continue. Electrolysis of molten or fused electrolytes. Fused state of electrolytes. For example, now I am taking NaCl. Already you know, electrolysis means the process of chemical decomposition of a substance by passing of current. Here now I am taking molten NaCl. On heating, it can dissociate into ions. These ions are responsible for flow of electrons. It is act as a anode. This electrode act as a cathode. The first step here, ionization or dissociation, decomposition or ionization. 2 NaCl dissociate into 2 Na plus and 2 Cl minus ions. This is called dissociation step. Here redox reaction takes place. A redox reaction means a reaction which both oxidation and reduction takes place simultaneously. At cathode, already you know, a reduction takes place. That means here 2 Na plus gains electron to form sodium. That means here the sodium metal is deposited at the cathode. Reduction takes place. At the anode, oxidation takes place. 2 Cl minus ions try to lose electrons to form Cl2, or 2 Cl minus try to lose 2 electrons. That means here we can conclude that in molten NaCl, at a cathode and anode, at a cathode sodium metal is deposited. At the anode, chlorine gas is liberated. I hope it is clear. In case, instead of NaCl, now I am taking here molten NaOH. What happens? NaCl, NaOH, which can dissociate into Na, 2 Na plus and OH minus ions. At a cathode, sodium metal is deposited. At the anode, reaction change here. OH minus ions are there. Two OH minus ions form H2O plus 4 of O2 electrons. At the anode, oxidation takes place. Oxygen gas is liberated. Okay, like that, if you take electrolysis of molten KNO3, I am taking here. K plus and NO3 minus ions are formed. At cathode, K plus ion gain electron to form potassium metal is deposited. At the anode, NO3 minus ion like that. It means oxygen gas is liberated at anode. Okay, this is information about electrolysis of molten Na. Molten NaCl. Now another one is electrolysis of aqueous electrolytes. Now I am taking here electrolyte or simply NaCl. Now I am taking in water. Aqueous form means water act as a solvent. Okay, now this is NaCl solution, aqueous form of NaCl. You can observe here dissociation. That means there are two substances are there, NaCl dissociate into 2Na plus and 2Cl minus. Water molecule dissociate into 2H plus and 2OH minus ions. You can observe here there are two cations and two anions are there. Before only one cation and one anion, there is no problem here. Okay, in case of two cations and two anions, when an electrolyte containing two or more cations and anions are present, we can use preferential discharge of one particular cation at cathode. Preferential, or it is also called discharge potential theory. Discharge potential theory. According to discharge potential theory, the deposition extent is inversely proportional to the deposition means liberated. Deposition extent is inversely proportional to the discharge potential. dP means discharge potential. Here electrochemical series is there depending upon the ease with which an element lose or gains to form ions. An element try to gain or an element try to lose electron to form ions. Okay, these ions are arranged in a vertical column circle electrochemical series. These electrochemical series are classified into two types: positive electropositive series, electronegative series. Okay, here what is the discharge potential theory said that when a solution containing two or more cations, here Na plus ion is there, H plus ions also is there, Cl minus ions are there, H minus ions. In this discharge potential theory, we can explain that when a solution containing two or more cations and anions, according to preferential discharge theory, the ion with lower potential discharge, lower discharge potential with deposit first, Okay, what is the order here, sir? Okay, the order of decreasing order of discharge potential for various anions or increasing order of cations. Here order is there. Based on that order, we should write. Now I am taking here order with respect to cation order. Now I am taking increasing order. First, noble metals like platinum, gold, silver, mercury, copper. These are called. So what is the principle of this one? Discharge potential theory. An ion with lower discharge potential will discharge first. An ion with lower discharge potential will discharge first. Now here Au plus 3 gold less than noble metals like Au plus 3, copper plus 2, Ag plus 1, platinum plus 2, and also gold, etc. here. Au plus 3, platinum plus 2, Hg plus 2 also. Au, Ag, Hg plus 2, platinum, Cu. Then followed by alkali metals. Next, then further followed by H plus ions, lithium ion, sodium ion, potassium, calcium ion, magnesium ion, aluminum, magnesium, aluminum, zinc, lead, nickel, etc. Okay, so if you take here anions order with respect to anion, with respect to anion, anion halides like Cl, Br minus, Br minus, I minus halides less than OH minus, sulfate ion, nitrate ion, etc. Then followed by fluoride ion also. Chloride, bromide, iodide, carbonate also. Some books starting carbonate, iodide, Br minus, I minus, Cl minus here. Then followed by further OH minus, sulfate, nitrate, F minus. Okay, this is the order you can observe here. Now I am taking cations Na plus and H plus ions. Which one is will discharge first? Lower discharge potential. H plus and Na plus. Which is lowest discharge potential? Always H plus ions. Okay, that's why the ion with lowest discharge potential will deposit first here at a cation, at a cathode, at cathode, H plus ions gain electrons to form hydrogen. That means hydrogen gas is liberated at cathode. At anode, OH minus and Cl minus, which one is a lowest discharge potential? Always Cl minus ion. Okay, these Cl minus ions try to lose electrons, half Cl2 plus 1 electron. That means at anode chlorine gas is liberated. At cathode hydrogen gas is liberated. Like that, anyone, okay, if the solution containing two or more ions, either cation or anion, by using of selective discharge ions, that is called migration of ions, and passing of direct current through an electrolyte in an aqueous solution or molten state, the ions are present in the starting migrate towards respective electrode. Cation migrates towards cathode side. Anode always migrate towards anions always moves towards anode side. This movement is called electrolytic or ionic conduction. Sodium chloride solution in aqueous solution, Na plus and OCl minus, H plus and OH minus ions are there. Na plus H plus ions are the cations, especially based on the lowest discharge potential theory. Lowest discharge potential species or ions migrate towards cathode side. Now I am taking Na plus and H plus ions. H plus ions the lowest discharge potential when compared to the Na plus ion. Okay, that's why here H plus ions gains 2 electron to form at cathode hydrogen gas is liberated, and Cl minus and OH minus ions. Cl minus is the lowest discharge potential when compared to the OH minus ion. Chlorine try to lose electron to form a chlorine gas at anode. This is information about electrolysis of aqueous solution. And we will continue one more video. That is here a selective discharge of the ions depending upon some factors. Before already what is this selective discharge ion means when electrolytes containing two or more cations. Selective discharge. Ions. It depends upon, that means when an electrolyte containing two or more cations or anions, then the preferential discharge of one of the particular cation at a cathode and one of the particular anion at a cathode is called at anode. One of the particular cathode at cathode, one of the particular cation at cathode, one of the particular anion at anode, then migrate, that is called selective discharge ion. It is selective discharge of ions depending upon some factors, that is relative size of the cation and anion or relative position of the cation and anion in a electrochemical series. Electrochemical series. Second one, it is depending upon the concentration of the ion in electrolyte. Concentration of the ion. Concentration of the ions in the electrolytes. And third one is temperature or nature of the anode, sorry, not temperature here, the nature of the anode. The relative position of the cation means already you know, lower position of the ion in the electrochemical series, greater is the tendency its discharge at respect to electrode to form an element. The lowest discharge potential easily deposit at a particular electrode. Second one, concentration of the ion means here, if you take diluted solution and concentrated solution, if you take NaCl in a diluted solution, NaCl in concentrated solution. In diluted solution, at cathode hydrogen gas is liberated, at anode chlorine gas is liberated. But in concentration solution, the Na plus and Cl minus ion is very high concentrated, or high percentage of ions are discharged. That's why Na plus at cathode sodium is deposited, at anode chlorine gas is liberated. Here at cathode hydrogen gas is liberated, at anode based on the discharge potential theory, at anode chlorine gas is liberated. Here nana at cathode high concentration of ions, percentage of ion, more ions are deposited in the solution. At cathode sodium metal is deposited, at anode chlorine gas liberated. This is information about concentration. And the nature of anode, the nature of anode determining the selective discharge of anion migrating towards. If the anode can be chemically non-attackable, like inert, such as iron, graphite, platinum, gold. The anode can be chemically attacked, such as nickel, silver, chromium and copper. Based on the attacking of the agents, these electrodes are classified. Nature of the electrodes. These electrodes are classified into two types. How many types? Two types. That is, here non-attacked or inert electrode. Nature of the electrode, they are classified into two types. That is, anodes are classified, electrodes are classified into here two types based on the nature of anode. Non-attacked electrode, it is also called inert electrode. Inert electrode. What is a non-attacked electrode? And a non-attacked electrode refers to the electrode which themselves do not take a part in the reduction. Okay, it is an electrode which does not participate in. Does not participating in the redox reaction, means oxidation and reduction reaction. Oxidation reduction does not participate. Here example for here, non-attackable or inert iron, graphite, platinum electrode, gold, etc. These electrode does not participate in the redox reaction. The second one is active or attacked electrode. Attacked electrode. So what is the definition of attacked? Okay, it is an electrode which themselves participating in the oxidation and reduction, which are participating themselves, which themselves are participating in the oxidation or reduction. Oxidation or reduction. And actually oxidation means electronation, reduction means de-electronation. Example for chemically attackable or active electrodes: nickel, silver, chromium, copper. Nickel, silver, chromium, copper are example for attacked electrodes. So it is also called active electrode. Another name of this one, active electrode. I hope it is clear. Thank you.